6th grade, Module 1, Lesson 25, Classwork. Example 1. Sam says 50% of the vehicles are cars. Give 3 different reasons or models to prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc. So, my first one, let's just look at the picture. So we have 3 cars and 2 trucks. So they're saying that 50% of the vehicles are cars. So first of all, let's say that our ratio cars to whole is 3 out of total 5 vehicles. So that's equal to 3/5, and 3/5, if we wanted to make that into a fraction or a percent, it needs to be out of 100. So I need to figure out how to get from 5 to 100. So 5 times 20 is 100. So if I do 3 times 20, that is 60 out of 100, which would be 60%. So I am going to disprove Sam's statement because there are more cars than trucks. So 60% of them, the vehicles, are cars, not 50%. So there's one way that we can model it using numbers. Another way, a second way, we could do let's do a double line diagram. So I'm going to split this into the cars and the trucks. 1, 2, 3, 4, 5. So we put zeros. 1, 2, 3, 4, 5. And then since it's out of 100%, I'm going to equally split the 100% into 5 equal parts. So 100 divided by 5 is 20. So we'd have 20%, 40%, 60%, 80%, and 100%. So if we have, let's see, I'll label this as car, 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 and then we have truck, truck, 3 cars, 2 trucks. So here, this part is equal to 60%. 3 cars, 60%. So there's another way to show it. And one more way, we could, let's see, I don't have much room to make a whole, well, let's do it. Let's make a 10 by 10 grid. Okay, so we have a 10 by 10 grid. Now, we know that 60% are cars. So, actually I'm going to do that in orange. 60% are cars. So I'm going to shade in 60%. So there's the cars. And then the rest are trucks. So 40% are trucks. So there's another way to show the relationship 3 cars to 2 trucks. How is the fraction of cars related to the percent? So we want to show how the fraction of cars, 3 out of 5, is related to the percent. So we took that, and up here, that was kind of what we did first there. We took that and we made it out of 100, because a percent is out of 100. You know, when people talk about giving 100%, that's because that's all you can give. You only have 100%. So we multiplied by 20 to create equivalent fractions. 3/5 is equal to 60/100ths, so that's equal to 60%. So we can say that since the percents are out of 100, the two are equal. 3/5 is equal to 60%. Use a model to prove the fraction and percent are equal. So again, that's pretty much what we did for number 2, but we can do it again. I'm going to split it into 5 equal parts, and we'll have, I'll do 0, 1, 2, 3, 4, 5 cars, and then we split the 100% into 5 equal pieces. So we can show that with 3/5 are cars, and 3/5 is equal to 60%. What other fractions or decimals also represent 60%? So there are many different examples of fractions you could give. So we know that 3/5 is equal to 60%, 60 out of 100. We could reduce that to make it 6 out of 10. We could, if we wanted to multiply both the numerator and denominator by 2, 6 times 2 is 12, 10 times 2 is 20, 12/20ths. We can go on and on. But at the decimal, there's only one decimal that could represent 60%, and that is 6/10ths, or if you wanted to add a 0 behind it, 60/100ths. And really, those are the only decimals, unless you wanted to add more zeros at the end, but they're all the same thing. Example 2. A survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Give a part-to-whole fraction for comparing happy participants to the whole. Then write a part-to-whole fraction of the unhappy participants to the whole. What percent were happy with their job, and what percent were unhappy with their job? So let's start with the happy. So out of 1,000 people, 700 were happy. So 700 out of a total 1,000 were happy. So percentage-wise, remember a percent is out of 100, so we could divide each of these by 10, because 1,000 divided by 10 gets us 100, so 700 divided by 10 gets us 70. So percentage-wise, this is 70%. So unhappy was, 300 participants were unhappy. So 300 out of the 1,000 were unhappy. And as a fraction, we need to divide by 10 to get this to be out of 100. So that would be 30 out of 100, or 30%, which makes sense because 70 plus 30 adds up to the whole 100%. Create a model to justify your answer. So let's do a tape diagram. I'm going to split it into, let's split it into 10. And since we're talking 70 and 30%, and out of thousands, I'm going to, on the top, skip by 10%. And then on the bottom, since it's out of 1,000 and we need to space it out by 10, I'm going to count by 100. Okay, so here we can show that 700 people is equal to 70%. And then the rest, if we wanted to show that the 300 people would be equal to 30%. So you can look at it either way on this model. Exercise 1. Renita claims that a score of 80% means that she answered 4/5 of the problems correctly. She drew the following picture to support her claim. Okay, so it looks like she has 1, 2, 3, 4 shaded rows shaded out of 5. How many are in each row? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is a 5 by 20, and 5 times 20 is 100. So there are 100 blocks in there, and she has 4 out of the 5 rows shaded, which would show 4/5. 1, 2, 3, 4 out of a total 5 are shaded, so she would be correct. Because total she has, let's see, she has 20 shaded there, 20 shaded there, 20 shaded there, 20 shaded there, which is equal to 80 out of the total 100 blocks, and those two fractions are equal. Let's see, how could you change Renita's picture to make it easier for Renita to see why she is correct or incorrect? So I would change it. She just doesn't need as many rows. She could have just made something like this and shaded in 4 out of 5. So I would simplify the picture. So there are 4 out of 5 shaded. And then up here, I forgot, if we wanted to say that that's equal to 80%, we could also do that, because 80 out of 100 is 80%. Exercise 2. Use the diagram to answer the following questions. So it looks like we have 0 to 5, and then 0 to 100%. So 80% is what fraction of the whole quantity? So 80% is down here, and that is equal to 4 out of a total 5. So it's equal to 4/5. 1/5 is what percent of the whole quantity? So 1/5, 1 out of 5, is equal to 20%. And 50% is what fraction of the whole quantity? So 50% isn't on here. 50% would be right in the middle of 40 and 60. So we want to know right here is right in the middle of 2 and 3 would be 2.5. So 50% is what fraction? Well, we would have 2.5 out of the total 5, but we don't really want that as a fraction. So let's make this out of, we can make it out of, start by making it out of 10. 5 times 2 is 10, and 2.5 times 2, 2 groups of 2.5 will be 5. So 5 out of 10, or if we wanted it out of 100, 50 out of 100. 1 is what percent of the whole quantity. So the 1 would be equal to this 5 because it's equal to 5/5. Because remember, these are all parts of the whole. So 5/5, that's equal to all of it, 100%. If you had all of it, you would have 100%. Exercise 3. Maria completed 3/4 of her workday. Create a model that represents what percent of the workday Maria has worked. So she's completed 3/4. So I'm going to make a tape diagram. I'm going to separate it into fourths. And then I'm going to separate it into the percentages. So if I were to break 100% into 4 equal parts, I would have 25%, 50%, 75%. So Maria has completed 3/4 of her workday. So 3 out of the 4 parts, which means she has completed 75% of the workday. What percent of her workday does she have left? So that would be this piece right here. She has, if she's completed 75%, 100 minus 75% is 25. So she has 25% left. How does your model prove that your answer is correct? Well, we can say it shows that 3/4 is equal to 75%, and the remaining 1/4 is equal to 25%. We can see that up here in our diagram. Exercise 4. Matthew completed 5/8 of his workday. What decimal would also describe the portion of the workday he has finished? We need to make this into a decimal, and we can do that by dividing. So I'm going to do 5 divided by 8. And I'm going to, since we're working with decimals, I'm going to put my decimal there and move it up. So 8 can't go into 5. I'm going to put a 0 there. 8 could go into 50. Let's see, 8 times 6 is 48. So that's as close as we can get. I have a remainder, so I'm going to put another 0 and keep going. 8 goes into 20 twice, and that would be 16. I'm going to keep going. 8 goes into 40 5 times, and 8 times 5 is 40. No remainder, so our decimal is 625 thousandths. And that's just asking for the decimal. So how can we use the decimal to get the percent of the workday? So one way that you can do it is we know that that's equal to 625 thousandths. Remember, we say the fraction when we say the decimal. It just comes out. And as a percent, that would be 62 and 5/10 out of 100 because we're just dividing by 10. So that would be 62 and 5/10%. Another way that you can think about it is we just need to multiply the decimal by 100. So you could just shift the digits 2 places to the left and you would get your answer. So it's multiplying by powers of 10, which is something we learned in 5th grade. Exercise 5. Complete the conversions from fraction to decimal to percent. Okay, 1/8. So let's do 1 divided by 8. I'll bring my decimal point. I'm going to add some zeros. 8 can't go into 1, but it can go into 10 one time. Bring down the 0. 8 goes into 20 twice. That's 16. 8 goes into 40 5 times. And no remainder, so that as a decimal is 125 thousandths, and as a percent, we just need to multiply it by 100, and we'll get 12 5/10 percent. 35 hundredths. So as a fraction, it would be 35 out of 100. If we wanted to totally reduce that, let's see, we can divide both of those by 5. 35 divided by 5 is 7. 100 divided by 5 is 20. So that's 35 100ths in simplest form, 7 20ths. And then as a percent, this is 35%, because we can either multiply the decimal by 100, or we could just look at 35 out of 100, and it's 35%. 84 5/10%. So we can divide, since when we multiply it by 100, when we have a decimal, to get to a percent, we could just go the opposite way and divide it by 100 to turn it back into a decimal. So if I divide that by 100, moving the decimal point 2 places to the left, and we would have 845 thousandths. So as a fraction, this would be 84 5/10 out of 100, but we really don't want a decimal within a fraction. So I'm going to multiply by 10 and make it 845 out of 1,000. Or we could have just looked at this and said 845 thousandths. Like I'm going to do with this one. This says 325 thousandths, so I'm just going to make this 325 out of 1,000. And then as a percent, all I need to do is multiply it by 100. So it's going to be 32 5/10%. And lastly, 2 25ths. So I'm going to do 2 divided by 25. I'm going to put my decimal and add some zeros. Hopefully I don't need all those, but so 25 can't go into 2, it can't go into 20, but it could go into 200. Let's see, 25 goes into 100 4 times. So it would go into 200, double that many, 8 times. And that is 200. So, I don't need any of those zeros because I have no remainder. So this is equal to, as a decimal, 8 hundredths. Or 8 hundredths, which would be 8%. Exercise 6. Choose one of the rows from the conversion table in exercise 5 and use models to prove your answers. Models could include a 10 by 10 grid, a tape diagram, a double number line, etc. I am going to use let's draw a 10 by 10 grid. And let's just go with the last one, this 8%, because then all I need to do is shade in 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. So that shows 8 out of 100 are shaded in, which is equal to 8%.